Have you ever noticed that it's harder to start pedaling your bicycle than it is to ride at a constant speed? Or wondered what causes your bicycle to move? Or thought about why it goes forward instead of backwards or sideways? Perhaps not, and you wouldn't be alone. It wasn't until the 17th century that Isaac Newton described the fundamental laws of motion that we understood the answer to these three questions. What Newton recognized was that things tend to keep on doing what they are already doing. So when your bicycle is stopped, it stays stopped, and when it is going, it stays going. Objects in motion tend to stay in motion, and objects at rest tend to stay at rest. That's Newton's first law. Physicists call it the law of inertia, which is a fancy way of saying that moving objects don't spontaneously speed up, slow down, or change direction. It is this inertia that you must overcome to get your bicycle moving. Now you know that you have to overcome inertia to get your bicycle moving, but what is it that allows you to overcome it? Well, the answer is explained by Newton's second law. In mathematical terms, Newton's second law says that force is the product of mass times acceleration. To cause an object to accelerate, or speed up, a force must be applied. The more force you apply, the quicker you accelerate. And the more mass your bicycle has, and the more mass you have too, the more force you have to use to accelerate at the same rate. This is why it would be really difficult to pedal a 10,000-pound bicycle. And it is this force, which is applied by your legs pushing down on the pedals, that allows you to overcome Newton's law of inertia. The harder you push down on the pedals, the bigger the force, and the quicker you accelerate. Now on to the final question. When you do get your bike moving, why does it go forward? According to Newton's third law, for every action there is an equal and opposite reaction. To understand this, think about what happens when you drop a bouncy ball. As the bouncy ball hits the floor, it causes a downward force on the floor. This is the action. The floor reacts by pushing on the ball with the same force, but in the opposite direction, upward, causing it to bounce back up to you. Together, the floor and the ball form what's called the action-reaction pair. When it comes to your bicycle, it is a little more complicated. As your bicycle wheels spin clockwise, the parts of each tire touching the ground push backwards against the earth. The actions. The ground pushes forward with the same force against each of your tires. The reactions. Since you have two bicycle tires, each one forms an action-reaction pair with the ground. And since the earth is really big compared to your bicycle, it barely moves from the force caused by your bicycle tires pushing backwards. But you are propelled forward.